Hello, dear students. I hope you all are fine. Okay, today we are going to discuss heating and magnetic effect of chapter 14. Let's start with the heating effect. So, this effect you are observing in your daily life, in your surroundings. For example, you charge your phone or operate television or car. Basically, what is happening here? We are converting one form of energy to another. For example, electrical energy is converted to light energy or chemical energy or heat energy. So different forms of energy. And when energy is converted to when some of the energy is converted to useful work, some amount of it's getting changed to heat energy. So it is called heating effect of the electric current. So next is where this heating effect is used. So this heating effect is used in many appliances. For example, electric iron, the press that you use at your home, or electric heater. Heater means the kettle that is used to make tea, or the electric room heater that is used in the winters to get warmth in our rooms, or hair dryer, and so many appliances. So these all appliances, when you note down carefully, these all have the coil of fire inside. This coil is called element. So this is very important. You should note down what is element. And when the current flows through this coil of fire or this element, it becomes hot, even red hot, and gives out heat. And this heat, this is called the heating effect, and this is the basic and major application of the heating effect in these appliances. But the amount of heat depends on the many factors. You should know about these factors. What are these factors? One is material and length, thickness of the wire. So depending on the different appliances, the wires thickness and material length, it would be different. Okay, you can define the heating effect like this, and this you can note down in your notebooks. When the current is passed through a conductor means through which current flows. So the thing through which current flows, that is called conductor. So when the electric current is passed through a conductor and the conductor becomes hot after some time, or red hot, and it produces heat, this happens. You should know why this occurs. Why? Because energy is converted from one form to another. When electric energy is converted to heat energy, and this effect of the electric current is called heating effect. Okay, next is fuse and MCB. Okay, you all must have seen the fuse at your home and MCBs. So fuse, what is fuse? You all must have heard about short circuiting or overloading. So fuse, it is a safety device to protect our system when there is excess of or when the current exceeds its limit. So it is made of such a material that when the current flows exceeds, then it melts and automatically the circuit is broken. So it is made with such a material, and it's a glass tube, and there is a current limit set. For example, the current limit is 2500 amperes. It's an example. Ampere is the unit for current, and the moment when the current touches 2501 amperes, that at that moment only, the material inside this fuse, the wire, it will melt and the circuit will be broken, as it was connected with the circuit of your home, or it is present in almost all the industries, and everywhere fuse is inserted to save our devices. So when the current limit exceeds, it melts away and breaks the circuit that protect our devices for getting fired or getting damaged. But these days we are using MCB in place of fuse. So most of the places MCB is used. You must have seen MCBs near your the switches of your ACs. And the full form of MCB is also very important. You should learn its full form. This is miniature circuit breaker. It also this you can see these switches. These switches will automatically turn off when there is overload condition, means when the current limit exceeds or when there are chances of short circuiting. So basically the current limit exceeds due to two reasons. One, there is overloading, means of so many devices are connected together, or short circuiting means even either the wires get wear and tear, means from so many years the same wires are getting used. So this was fuse and MCB. Next effect is magnetic effect of electric current. So in this chapter you will study two effects. One is heating and other is magnetic effect. Magnetic effect you can understand through an activity. You have taken one cardboard, this simple matchbox, empty matchbox, and coiled a wire around it, and inside you have put the magnetic needle that always points in the north south direction, and the free ends of the wire that are connected to the cell with the switch and then with the bulb. And here this magnetic needle, when we bring a magnet near this needle, it starts getting deflected means it starts shaking, moving continuously, and it is not stable at one place. It is continuously moving in any of the direction. Otherwise its rest position is north and south. Or at the same time, if we pass the current through this wire, then also there is deflection in the needle. That means if we pass the electric current through the wire, it start acting as a magnet, and the needle shows deflection. It behaves as a magnet. So this is called magnetic effect of electric current. And the scientist Hans Christian Ørsted, he was the first to show this, that the electric current also produces magnetic effect through this activity. So this was all about these two effects. Thank you. Have a nice day.